Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be taking a look at OpenSSH. I'm going to tell you 8 things about it you probably didn't know. Stay tuned right after this. OpenSSH did not start out as an open project. It started out as a commercial project. It was designed to replace the shortcomings in first FTP, but also to replace the shortcomings in the R commands that were coming from Unix. So OpenSSH provides secure remote access and file transfer capabilities from a client to a server. It's the most widely used of all the SSH protocols, and there's a number of implementations of SSH, both open source and commercial. OpenSSH is included by default in all of the major operating systems, Apple's Mac OS, BSD, Linux, Solaris, and Windows. So it didn't always used to be on Windows, but recently it's been added. It was developed by Tatu Yavan at Helsinki University of Technology in 1995. There was a open version of SSH that was created in the same year, 1995, and that particular code base was used by Niels Provost, Theo DeRat, and Marcus Friedel in 1999 to create OpenSSH. And that was ported onto OpenBSD, which was the first platform to actually have OpenSSH. And in fact, I believe that's still where the project survives today as the initial point for all the changes that come to all the other platforms, including Linux. Damian Miller and Philip Hands and others, they ported OpenSSH over to Linux in the same year, 1999. So we've had it for a while. But what does it do? So the first thing it does is it encrypts the remote access, and it creates a tunnel which allows me to insert insecure protocols like FTP, R shell, and some of the other things along that encrypted tunnel to protect and encrypt and prevent eavesdropping of that data. It also encrypts file transfers, which FTP did not do originally, and it runs remote commands, programs, and script. But it does replace R shell, R login, Telnet, and FTP. But what does OpenSSH prevent? So it's really designed to prevent eavesdropping of data that's transmitted over a network. There are 2 tenets. First is encrypting of data at rest and encrypting data in motion. Those are 2 tenets of security. So this is really addressing the encryption in flight. So it prevents the manipulation of that data at the intermediate elements in the networks, for example, routers. Now, some protocols, in order to cross a routing boundary, have to decrypt and re-encrypt on the other side in order to continue on, but SSH does not need to do that. It also prevents address spoofing where an attack host pretends to be a trusted host. It actually creates a fingerprint based on the host key to determine whether or not that host is indeed the same host that was initially set up. It also prevents IP source routing using the source address instead of the destination address to determine the routing. So not something you would really want to have happen. So what doesn't it do? What are some of the things that it won't do? What can it not protect us from? So, I mean, obviously you can't fix stupid. I mean, if I misconfigure my SSHD config file or my SSH config file for the client side, I could leave my OpenSSH services in a state which they're not fully protecting my data, or maybe I'm employing an algorithm for encryption or a key link that is insufficient to prevent eavesdropping of the data as it traverses the network. Also, I mean, obviously it's not going to protect you from misuse or abuse. One of the other problems with it is that in a compromised system, particularly when the root account is compromised, eavesdropping is simple. You just eavesdrop on the sudo TTY on either side of the SSH exchange, and you have access to the command channel and the data channel, so you can see everything that's going on, including the user and the password. It also won't protect you from insecure or inappropriate directory settings. So if my permissions are set incorrectly on a home directory, or maybe the ACLs aren't set up correctly, then a hacker could change the files in my home directory in such a way as to fool SSH into connecting to the wrong server. There are config files that you can change where the hosts are located and which hosts go where. That would override your network settings in locating the host. So yeah, you could fool SSH. You could have it use less secure protocols in the encryption mechanism, which would allow them to decrypt messages as they traverse the network. There are 3 protocols that we're going to talk about today, and the first one is the SSH Connect. The SSH Connect protocol is inside of the SSH service, and it manages the SSH session. It performs session multiplexing and X11 forwarding, TCP forwarding. It offers shell access, remote program execution. In some cases, it does have an ability to invoke the SFTP system, but OpenSSH has a separate application for that. One thing I will say is that it is possible to connect to one server, and in that same command, you can specify that you want that server to in turn connect to another one. So you can create a server chain, like if you had a Bastion host and you were using that to access a remote server inside. You can do that sort of thing with SSH. And that is all handled by the SSH Connect. There's also a user auth protocol, which is inside of SSH as well. This is responsible for the authentication of the client and server side. There's a number of mechanisms here that you can choose from. There's the default password authentication, which uses the standard Linux user ID and password. There's also a public key or host-based authentication that you can use, and we'll talk about that some more in a bit. You can also use challenge response. There's also a pluggable authentication module support within PAM and also within SSH that allows you to take advantage of things like Active Directory or LDAP or Kerberos if you prefer to do your user auth and auth. There's generic security services APIs as well, such as the GS API. There are even dongles or common access cards, CAT cards, that you can use as well. Part of the PKI spec to initiate your authorization standards as well. The diagram on the right talks about this is kind of the setup that takes place, and in the end, once you have the command channel established and the data channel established, you end up with 4 processes in total. Where the protocols kind of fit in is in this activity diagram. We've talked about the connection, the auth, and so we're working kind of backwards, and now we've got trans. SSH Trans, that provides server authentication, so this is our fingerprinting. It also provides confidentiality and data integrity. It is here you'll find the support for SSH 1 version 1 protocol and version 2 protocols. It's a slight difference between them. SSH 1 uses both the server and host keys to authenticate. SSH 2 only uses the host keys to authenticate. So SSH 1 is considered less secure than SSH 2. So most of the OpenSSH default to SSH 2. You'll find out, however, if you're running Linus, it expects an explicit declaration in your systemd config file where you would enter protocol space and a 2 in order to actually make sure that you're on SSH 2 version 2 protocols. This is more of an application than a protocol, but FTP is a protocol, and so SFTP is as well. I noticed that when I was putting together the research for this today, I kept hitting FTPS. That's the one problem you have with search engines, is that they're not based on the right answer, they're based on the popular search terms. So apparently there's a lot of people looking, or maybe they're confused between FTPS and SFTP. FTPS is an older protocol, and it was really meant to fix the problems or attempt to fix the problems in FTP. So FTP and FTPS both have two channels, two communications channels or two sockets that get opened. The first one contains the command channel, and that's where you pass your login, your connection to the host, your login to that host, and then you issue commands to get a file or to receive a file. The problem with FTP and FTPS is every time you initiate a send or a receive, your data channel gets created anew. So there's a new socket, a new port that gets opened each time there's a new transfer. That in turn gets closed down, and then your TTL, your normal TCP time to live, then extinguishes that port that was open and gets it out of the system eventually. But yeah, it's not a particularly fast protocol, not a very particularly secured one either. SFTP, in contrast, only uses one channel for both the command and the data. So you're not repeatedly opening and closing channels or ports. There's quite a bit of overhead in setting up a socket connection and tearing one down. So yeah, that's additive. So if you're doing a lot of file transfers with FTP or FTPS, it can take quite a while to transfer those files. SFTP, because there's only one channel, it encrypts both the command and the data channel. Now, FTPS, it uses a wrapper around FTP using SSL and TLS. So FTPS is not an optimum solution. The other problem with FTPS is that, yes, you can encrypt both the command and the data channel. However, the default is only to encrypt the data channel. So they don't bother to encrypt the command channel a lot of times. And so, or it might be the opposite. I have seen both, where the command channel was encrypted and the data channel wasn't. So you have to go in and configure it to get both of them turned on. And it can be complex, and it can be hard to set up and get it right. So, I mean, I just, FTPS, it's an old thing. Just leave it alone. As far as FTP is concerned, it's inherently insecure, and it has been for years. As far as other SSH implementations other than OpenSSH, what else is there? I mean, this, again, is not a complete list. It's just ones that I know of. There's a DropBear, which is meant for embedded systems, so it's kind of a very cut-down version of OpenSSH. It's very modular, it's open source, it's also very quick, and it's very lightweight. Our Tectia is a product, it's a commercial product from SSH Communications Security Corporation. It is closed source, but it does offer SSH Client. In other words, it offers terminal services as well as file transfer. It does do the command layer as well, so you can do remote execution. The only thing about it is that, I mean, that was the first thing I used because obviously OpenSSH wasn't around yet. It was fairly expensive of a product, and Oracle Solaris also has their version called Secure Shell, and it's a fork of OpenSSH 2.3. So they've had it for a while, and I don't know if they go back and periodically update theirs from a new fork, but the last information I have was it's based on 2.3. That was probably the original version, to be my guess. There is GlobalScape EFT server, and that also includes modules for SFTP and SSH as an extension. GlobalScape EFT server has all kinds of security protocols in it, depending upon what. As far as GUI clients for SSH and SFTP, you'll find that there's not too many SSH clients anymore. It used to be that SSH and SFTP were kind of hand in hand, but most implementations today are done with file managers, and so there's no need for terminal access or remote execution, so they just implement the SFTP portions. Bluefish is one of those, and it's used to keep your website updated. So you also have CyberDuck, which is a remote file browser for the Mac. Dolphin is another one that's available for Linux. That is actually a file manager for KDE, and it also has built-in SFTP support. Fetch is an SFTP client for Mac. Been around a long time. FileZilla is a FTP utility that includes SFTP support for multiple platforms. It's been around a long time, Windows, Mac OS, Linux, and there is a commercial version of that as well. FireFTP is a FTP plugin for Mozilla Firefox. It's been around a long time as well. I believe WaterFox has that inbuilt, has FireFTP inbuilt. Now Mozilla doesn't. You have to install the extension if you want it. Fugu is an SFTP GUI frontend for the Mac. There's also GFTP, which is a multi-threaded file transfer, which supports SFTP. There's also Juice SSH. Now that is a SSH client for both Android and Linux. Conquer is also a file manager and a document viewer for KDE. It's another one. It also supports SFTP. LFTP is a file transfer application that includes SFTP support. I know it's on Linux. I don't know what other platforms that might be found on. I don't use it. Nautilus, GNOME Desktop File Manager, also supports SFTP. There's also PCMan FM, which again is a file manager, this time for LXDE, and it also supports SFTP. PuTTY has been around a long time, and that's the Windows implementation of SSH and SFTP protocols. Now, of course, Microsoft now has native OpenSSH support, so if you need PuTTY, I don't know, do you? Yeah, you might. It depends. PuTTY is a GUI. The Microsoft implementation is PowerShell or shell-based. There is SecPanel, and that runs SSH sessions and SCP connections, so it allows you to manage your hosts there on which ways you're going to connect. Terminus is a full SSH implementation for iOS. I believe it's commercial. It offers the terminal and SFTP side of things, so it's a complete, as I said, a complete SSH solution. Thunar, file manager for XFCE, that's on Linux, of course. That's one of the desktop managers, and that also supports SFTP. There's WinSCP, which is a GUI FTP client for Windows. That includes support for SFTP and SCP. Now, we haven't talked about SCP. SCP is actually a utility, and it's used to copy files and directories. So you can do one file or many files, one directory or many files. You can do recursive copies throughout, down through a tree of directories to copy files from one machine to another. One of the other things that I would add in here that I didn't was SSH file system for Linux. So that uses the SSH protocol and allows you to actually mount a file system off of a remote host, and that uses SSH to do and manage the movement of data. There's also yet another file, FTP client, or FC, and that also supports SFTP, although FTP is the default. What about utilities? So SSH comes with a number of utilities. There's a SSH agent that allows you to hold your private keys in memory. So if you're going back and forth for a number of systems a lot, this just saves you the overhead of having to re-fingerprint and check and your private keys so that they're available to the system for encryption and logins and session management. And to add keys to it, you just do an SSH add, and it'll add your key to the memory that you can then reuse during the session. You can also use SSH add to delete keys. So, funny way to say it, you can add, but then you can give it an option minus lowercase d, and it'll remove them. There's also SSH key scan. That retrieves your public key, and it'll check the fingerprint to make sure it's authentic and it looks proper. There's also SSH keygen, of course, and that's how you create your private and public key to begin with for SSH. You can also manage and update and verify the keys there. SSH copy ID installs the public key into the remote machines. So that comes down to program languages with SSH bindings. You probably wonder, why would you put that in here? Well, one of the big complaints with SSH is it's not very prevalent. It's not an official protocol, and it isn't really included in all that many applications. So The bindings are for the developers if they want to implement SSH within the application that they're writing. You have libSSH, which is an older library. It supports both V1 and V2 protocols. SSH2 only supports V2, so a nice security feature. Perl has various bindings available for SSH support. Python has Paramiko, Fabric, and libSSH2 as well. So Ruby has NetSSH and Capistrano if you're writing applications in Ruby, and Rust has an SSH2 crate that supports SSH v2 only. Java has Jargon and JSCH implementations of SSH2. OpenSSH, things to be aware of. So because your messages are encrypted, obviously it's going to have overhead, right? It's going to be slower to move the data because you have the extra time involved in encrypting and decrypting messages. Also, SSH employs a symmetric encryption mechanism where the messages are exchanged between two systems, so the only way you can be sure that it's safe from eavesdroppers is make sure the encryption method for the system is not known, so that there's no way to discover that. Also, the key length needs to be of sufficient size when you're generating your keys. Now, probably the best thing for me to do here is to say I plan on doing another video to go through this. The encryption and decryption of messages, and so probably I don't know which ones you should use and shouldn't use, which ones have been broken and which ones haven't been. And because SSH is not a standard for communication, it's not normally implemented in most programs, and that's the reason why I added the binding. So just a couple of closing thoughts on what we did today. So we talked about what OpenSSH can and cannot do. We looked at the protocols involved. We looked at the protocols involved in protecting the authentication and the transfer of data. We've also looked at what server implementations are available to support SSH, the GUI client implementations as well, and also we talked about some of the utilities that you might find. There are others, by the way, and so the next video will cover some of those as well. Also, what SSH bindings are available in various development languages. Clearly, whatever you do, you need to be careful about what algorithm you choose and what key length you choose. There have been times, I'm not gonna mention specifics, but there have been times in the past where we have conducted key strength tests on various encryption algorithms and found issues, even in some of the newer ones. So, I mean, I'm not saying that they're insecure, but I would say there are concern about some of that. Is all I had for today. That's all I had for today. Hope you enjoyed this. If you did, please like and subscribe. Let me know down below what you're using for your client and your server. Are you using Dropbear? What are you using? I'd like to know. Have a good one and see you next time. Bye for now.